Hi viewers, in this video we are going to discuss about the one of the important question in the chapter of current electricity, that is define electric resistance and write its SI unit. How does the resistance of a conductor vary if a conductor is stretched to 4 times of its length? Temperature of conductor is increases. First thing is we have to define the electric resistance and we have to write its SI unit. And next thing is what happened to the resistance of a conductor when conductor is stretched to 4 times and temperature of conductor is increases. So that is the question we are discussing in this video. To understand complete concept, you have to watch the video without any skip. Clear, children? So dear students, what is mean by resistance? Resistance is nothing but the opposition shown by the conductor to the flow of electricity. That should be called resistance. Clear? When the current is passing through the conductor will show some opposition to the current. That kind of property is called resistance of the conductor. It's very clear. And next thing is here you write the definition also. You have to write simply here what I am saying: opposition shown by the conductor to the flow of current is called resistance. What we call, children, that is resistance. And next thing is what is its SI unit? Resistance can be measured. It can be measured in terms of ohm. In terms of ohms. Ohm is the unit for resistance and that should be shown by the symbol like this. So unit of resistance is what? Ohm. The opposition shown by the conductor to the flow of current is called resistance and that should be measured in terms of ohm. And children, you can write the electrical resistance in another form also. What we know, V is equals to IR. From that what write? R is equals to V by I. Here for example, this is the one conductor and the potential difference between these two conductors is V and the amount of current is passing through the conductor is I. The ratio of these two is called resistance. The ratio of potential difference between the ends of a conductor to the amount of current passing through the same conductor, that should be called resistance. You can write this definition also: R is equals to V by I. And again the same thing is what? The unit is ohm. Now the second part of the answer, let's go for that. Yes, here you have to consider 2 points. So what is the formula here, children? R is equals to rho into L by A. R is equals to rho into L by A. Children, when rho and A both are constant, then we can write R is proportional to A. Clear? When we get this one, when resistivity and area of cross section, resistivity and area of cross section both are constant. Area of cross section are constant. Now in this case here we will write R is equals to rho into L by A. So I am multiplying these two are like this. And what you get? R is equals to rho L square by A. Rho L square by A. And now what do you write? R is proportional to L square. R is proportional to L square. Why? Because here we will write this is rho into L by A. We are multiplying the numerator denominator L. Then what do you get? Rho L square by AL we get. What is AL means what? Nothing but here rho L square by V. V is what? Volume constant. Clear? R is equals to rho L square by V. It means that what? Here Rho is the resistivity, V is the volume. then what is the condition? R is proportional to L square. So in this case we are using this condition, R is proportional to L square. That means what? R1 by R2 is equals to L1 square by L2 square. So what was given? R1 by R2 is equals to L1 square by, and 4 times stretch this is what? L2 is equals to 4L1. So 4L1 whole square. That means what? R1 by R2 is equals to, again what, right? L1 square by 16 L1 square. L1 square cancel. Then what do you get? R1 by R2 is equals to 1 by 16. Then R2 is equals to what we get? Yes, 16 into R1. Clear? So the resistance is increased by the 16 times. 16 times when volume and rho are constant. Clear? So when only we will consider length and area, we will write the formula rho is proportional to L. So when automatically length is stretched, area is decreases. Area is decreases. That's why you can use this formula here. R is proportional to L square. Got, children? So simply what, right? Resistance of conductor is increased by 16 times. Resistance of conductor is increased by 16 times. What happens to the resistance of a conductor when temperature is increased? So children, all of you know, getting heat of any conductor is only because of resistance. Clear? While the current is passing through the any conductor, it will show some opposition. Due to that, the material or the conductor is going to be heated. When it's heated, temperature is increased. Obviously, what you have to say? When temperature increases, resistance also increases. Or when resistance increases, temperature is also increases. So finally, what you have to conclude? There is directly proportionality between the conductor resistance and temperature. So that should be easily explained by the formula here. At temperature T1, resistance is R1. At temperature T2, resistance is R2. Clear? At temperature T1 degree Celsius, resistance is R1. At T2 degree Celsius, resistance is R2. Then obviously here we have one formula is there. R2 is equals to R1 plus alpha into T2 minus T1. So from that formula we can easily say that R2 minus R1 is equals to alpha into T2 minus T1, where alpha is constant. Then what we write? R2 minus R1 is proportional to T2 minus T1. So that means the increase in temperature, is can influence the increase in resistance. The resistance increase or the increase in the resistance is directly proportional to the increase in temperature. So finally what you have to say? Resistance is directly proportional to temperature. Directly proportional to the temperature. Okay children, so this is about the answer of this short question. I hope you understand. Dear students, if you want other topics in the same chapter, already current electricity playlist is there. In that you have to check the remaining all the concepts belongs to the intermediate second year current electricity chapter. Okay, thank you for watching.